Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and we are talking about the welding joining of the metals, where in the last presentation I have talked about the weldability or the ease of welding, but in this presentation initially I will talk about the welding defects, and thereafter I will take up the fundamentals related with the heat treatment. So, the common types of the defects which are defects and discontinuities which are observed in the weld joints, it includes like the cracks of the different types, which may be solidification crack, cold cracking, which this is also known as hydrogen induced cracking, and then liquation crack, which is obtained next to the fusion boundary. So, liquation crack is observed in next to the fusion boundary, especially in the high solidification temperature range LYs, and then underbead cracking. Solidification crack is mostly observed at the center line of the weld joint. Cold cracking occurs mostly in the weld metal and also in the heat affected zone. Liquation cracks occur near the fusion boundary, and underbead cracking occurs below the weld bead, maybe in the heat affected zone, near the heat affected zone, due to the suppression of the metal and the inclusions due to the tensile residual stresses which are acting in the weld joints. Apart from that, there is a lack of, another important defect is lack of penetration and the lack of fusion. Both of these defects are caused by like say, in order to identify the lack of penetration or lack of fusion, like this is the groove which has been made, and when the welding is done, due to the limited heat, metal just get deposited over the surface of the metal, but there is no melting. So, that is called the lack of fusion, means in that case fusion is not there, and when the fusion is there but the penetration is limited, then it leads to the situation of the lack of penetration, and both these kind of the defects are caused due to the low heat input or the less H net than the required value. So, which is leading to the deficient melting or less melting of the limited melting of the base metal or no melting of the base metal, just molten metal is getting deposited over the surface. So, this kind of defect is simply taken care of by increasing the welding current in case of the arc welding, or by slowing down the source of the heat, whether it is the laser beam, electron beam, or your any arc speed or the flame speed. So, whatever is speed, whatever the source of heat is being used for the fusion purpose, is speed of that is reduced, so that H net can be increased, because H net normally is found inversely proportional to the speed. Higher is the speed, lesser will be the heat input. So, increasing the factors, increasing the heat being generated through the suitable control of the process parameters, or reducing the speed, helps in overcoming the issue related with the limited penetration. So, now coming to the cracking related aspects, solidification cracking, which occurs mostly along the weld center line, especially in case of the high solidification temperature range LYs. So, in order to overcome this, basically efforts are made in such a way that the residual stress magnitude is reduced, and the restraint conditions under which welding is carried out, that is reduced, and also it is done in such a way that the grain structure, the impurities, the weld metal composition is modified in such a way that such kind of solidification temperature range can be reduced. So, suitable selection of the filler metal, considering the dilution, is also kept in mind while selecting the filler, so that the composition of the weld metal is such that solidification temperature range is reduced. So, these are and then the grain structure is refined. So, these factors actually be helping to reduce the solidification cracking tendency. Cold cracking is mostly caused by the high hardness being caused due to the martensitic transformation, high hardness, and development of the tensile residual stresses. These are the 3 prime factors which are required, 3 or 4 factors, and the hydrogen concentration in and around the weld zone. So, in order to this kind of the cracking, cold cracking is also called delayed cracking because it occurs after some time of development of the weld joint. So, in order to take care of these factors, basically preheating is one of the important step which is taken. So, preheating reduces the martensitic transformation, reduces the hardness, reduces the tensile residual stresses, as well as allows the diffusion of the hydrogen from the weld zone effectively. So, preheating, depending upon the kind of the carbon content and carbon equivalent in the steel, maybe from 150 to the 300 degrees centigrade preheat can be applied. Then another is the selection of the suitable filler, means such kind of fillers like austenitic stainless steel and the nickel alloys which can accommodate the hydrogen in the weldment, which can accommodate the residual stresses easily, are also used for controlling the cold cracking. Because these will be helping to reduce the residual stresses, as well as these will be accommodating the residual stresses, as well as these will accommodating the hydrogen which is present in the weld metal. Reduction in the heat input is basically used for as I have said, liquefaction cracking is caused by the wider solidification temperature, and so limited heat input is one of the method. Preheating is also helps in reducing the liquefaction cracks. And for underbead cracking, underbead cracking and the cold cracking factors are almost similar kind of the factors, wherein high hardness, hydrogen content, tensile residual stresses, and the martensitic transformation or high hardness of the heat affected zone, all these factors contribute significantly. So, reducing the residual stresses, reducing the restraint conditions under which welding is being done, increasing the preheat, and using the filler metals like the nickel or the austenitic stainless steel, they will be permitting the softer weld as and they will be reducing the residual stresses, which will be decreasing the tendency for cracking under the underbead or below the weld bead which is being deposited. Since this kind of bead is formed below the weld bead, that is why it is called underbead. And mostly the main cause of the underbead cracking is the jet direction, limited jet direction ductility, which occurs due to the presence of the silicate inclusions or inclusions in the steel. So, under the tensile residual stresses, these tend to get delaminate or means separate from the metallic matrix. Say for example, this is the weld joint, and if the tensile residuals are being developed and inclusions are running in this way, then the separation of the inclusions from the metal matrix can lead to the development of the underbead cracks. Apart from this, there are issues related with the improper selection of the welding parameters, careless deposition of the molten metal by the welder. So, that will be leading to the unfavorable shape of the weld bead, which may be in form of like say over reinforcement in this manner. So, the reinforcement height is too much, leading to the higher stress concentration at the toe of the weld, or the underfill in the weld like this. So, the weld cross sectional area is reduced, or it may be leading to the presence of the these kind of undercuts due to the unfavorable selection of the welding parameters. So, this is undercut. So, these are unfavorable shapes which are normally not accepted when these kind of shapes are generated during the welding. So, proper care is needed in order to avoid such kind of the undesirable shapes, and for this purpose proper control over the manipulation of the weld metal, proper deposition of the molten metal, proper selection of the welding parameters is important. Welding parameters in terms of the welding current, arc and open circuit voltage, and the welding speed, these help in controlling the unfavorable discontinuities in the weld joints. Now coming to the another important aspect of the manufacturing. So now we have talked about the four broad and main manufacturing processes so far in this course. These were like the casting was one, was primary shaping process, then the forming was another deformation based approach for also changing the shape of the bulk materials through the deformation based approach. And then we have talked about the machining, and machining is the process wherein unwanted material from the stock is removed in order to get the desired size and shape. And then we have also talked about the joining process, which is a positive process. Simpler shapes are brought together in order to get the desired size and shape through the joining. Now the fifth category is the property enhancement, properties improvement of the components being manufactured. So this property enhancement can be in the number of ways, but there are two broad categories about which we will be talking. One is the bulk material properties, where the heat treatment means thermal treatment to the material is given for the variety of purposes, and the second is only the surface properties. So here entire bulk material properties are modified, and here only surface properties are modified. So under the each of category there will be different functions which will be realized, like say these when heat treatment is carried out of the bulk materials, it is done for different purposes, so that the one of the main purpose is to reduce basically to change the structure of the bulk materials, so we have the desired combination of the mechanical properties. So mechanical property improvement means mechanical property alteration is one of the objectives of the heat treatment, so that it can be used for the given purpose. Another is stress relieving or reducing the residual stresses being developed in course of the manufacturing by different processes. Say it is either the heat treatment, or say it is the casting, or the machining, or the welding. So in all those cases, if the residual stresses are being developed, they will be degrading the mechanical performance of the weld of the components. So we want that residual stresses are relieved. Then it is also done to facilitate the further processing of the metals, especially in case of processing of the metals, especially in case of the like cold working. We know that whenever the deformation based approaches are applied, material gets a strain hardened. So a strain hardened material will be leading to the increase in strength and hardness and reduction in ductility, which makes the further mechanical working difficult. So we need to do the means softening of the material, which is done through the process annealing. So one of the purposes of the heat treatment is to facilitate the further processing of the material because of increase in hardness and ductility in mechanical working process like cold working. So that will be reducing the ductility, increasing the hardness, making the material difficult to process further. So cold drying or the cold rolling kind of processes are those where it may be required to do the process annealing. And then there may be whenever it is done sometimes to induce the softness in the metal, so that it can be processed by the conventional processing. Like in the material may be very hard, may be very of the limited ductility. So if the heat treatment is done, then it allows the deformation, machining easily. So even some of the materials, when they are heat treated, they get softened, and in the soft state they can be conventionally processed easily, either by machining or the forming or by deformation processes. So softening is normally done in some of the cases in order to facilitate the manufacturing processes so that they can be processed further. So, heat treatment is one of the big category for the bulk material property modification through change of the structure, which is done for improving the mechanical properties, reducing the residual stresses, facilitating the further processing through the process annealing or inducing the softness in order to ease out the processing of the metal. For example, copper is normally processed. Similarly, the steels are also heat treated if they have been hardened so that they are machining and the deformation can be facilitated. And then another category is the surface property enhancement. Surface property enhancement, there are various groups among the surface property enhancement, like one is where surface composition is modified, another is no composition modification, only structure is modified through the application of the heat. Then there is the mechanical deformation is applied at the surface, no heat. So, in this case basically the thermal treatment is done. Here the chemical modification is applied. Here just mechanical deformation like shot peening and sandblasting kind of the methods are applied. And then there is one more where the coatings, claddings, etc. are applied at the surface so that the properties of the surface can be enhanced. So, these approaches are based on like this is the surface whose properties need to be enhanced. So, what we will be doing? We will be introducing, according to this compositional modification approach, we will be introducing the composition alloying elements suitably in the bulk material, like it may be like for aluminizing for aluminum, vanadizing for vanadium, then siliconizing for silicon, and for chromizing for chromium, and then carburizing, carbon is introduced, nitriding, nitrogen is introduced. For carbonitriding, carbon and nitrogen both are introduced at the surface of the materials, so that the compositional modification depending upon the process, this depth may be very less or may be very high, maybe like say 2000 3000 micrometer to like say just 5 to 10 micrometers depending upon the process which is being used. Another method is where just thermal treatment is applied. In this case the component those kind of metal systems which experience the structural modification whenever the heat is applied. So, the controlled heating followed by the cooling. So, heating followed by the controlled cooling results in the structural modification near the surface. So, this is the kind of approach which is used for modifying the structure as per the requirement, so that this property near the functional surface at the means the properties of the metal at the functional surface can be modified. This is what is tried in case of the no compositional modification, just a structural modification is applied. So, laser hardening, flame hardening are this kind of the methods where no composition modification, only the structural changes are brought in at the surface of the material. Third approach is where the deformation is applied. So, in this case either like say the control rolls or the shot blasting is done. So, the controlled near surface layer deformation is achieved, and this kind of the deformation leads to the work hardening or strain hardening of the surface layers, and also develops the residual compressive stresses at the surface due to the near surface layer deformation in very controlled way. So, this way we will be getting the improved fatigue resistance, improved hardness of the material. This is another approach, and the coating and the cladding, coating and cladding is another approach where in the bulk material whose only surface properties need to be improved. So, we will be selecting the suitable material which can really offer us the properties which can be we will be selecting the suitable material so that when it is applied onto the surface of the metal, it offers the properties desired. So, there are a number of methods for depositing the coatings as well as claddings. So, like the thermal Spraying is one of the category of the processes where the thin layer of the coatings is deposited depending upon the kind of the metal systems. The coatings may be like say 20 to 2000 or 4000 micrometer in thickness. So, harder is the metal, lower is the thickness, and softer is the metal, greater is the thickness of the coating which is normally deposited through the number of thermal spread coatings. So, in this case approach is that the bulk material surface is covered using the suitable material whose properties are desired. So, in this way we get the properties of the material which has been coated, so that the functional performance of the surfaces can be improved, while the underlying material does not affect the properties of the underlying materials of the base metal are not affected. So, basically it is just like enclosing the base metal which will be taking the load, but special functional properties at the surface like high hardness, good corrosion resistance, good lubrication properties, all those are offered by the material which is deposited or cladded at the surface. Yeah. So, coming to the fundamental principles related with the heat treatment for enhancing the properties, basically the one simple approach is used in the heat treatment. If you just forget for a while the approach for reducing the residual stresses. So, enhancing the properties of the bulk materials using the heat treatment, which basically involves the heating of the material followed by soaking, so that uniformity in the temperature in the component being heat treated can be achieved, and uniformity in the phases present in the bulk material can be realized, and thereafter controlled cooling is obtained. So, this is the kind of combination which is used for any kind of the heat treatment process. So, depending upon the kind of the metal systems, the different types of the heat treatments are there, but the general approach in all those heat treatment process is simple, where the properties desired, properties required, or like say for a given functional purpose what are the properties are needed, those are identified, and based on the properties required we try to alter the microstructure of the bulk material through the controlled heating and cooling cycles. So, the microstructural modification in the bulk material is realized through the controlled heating and cooling, so that we have the desired structure and so the properties. So, altering of the microstructure is one of the main approach in the heat treatment, wherein we will be realizing the desired combination of the properties or property enhancement in the bulk material. Structure has the two main aspects, one is about the phase structure and another is about the grain structure. When we talk of the phase structure, means a bulk material made of the number of crystals. So, what we say, this is a polycrystalline, or then it is made of the number of grains which are also may be termed as the different phases which are there. So, when we talk of the phase structure, which means the type of phases which are present in the metal, like there may be just 1, 2, A, B, C, D, how many phases are present, like a metal may be having just A and B, like in low carbon steels there may be like ferrite and pearlite, or pearlite and cementite. Similarly, in aluminum silicon alloys, like it is aluminum, then aluminum silicon eutectic. So, depending upon the kind of the metal systems, there can be the one or more number of the phases. So, what are the different types of phases which are present in the metal and their relative amount, since each phase offers a different set of the properties. So, if the soft metal is present in more proportion as compared to the hard phases, so in general metal will be of the lower strength and the lower hardness. So, the relative amount of the different phases, like soft phases 10% and hard phases 90%. So, like in low carbon steel may be having the 80% of the ferrite and 20% of the perlite. So, it is about the proportion of the different phases or the relative amount of the different phases which are present. And third is the distribution, where what is present, it is about what is present at the boundary, what is presented within the grain, or like in the casting or in the welding. So, if we see, there may be possibility that this portion may have one kind of phase, this may have another kind of phase, this portion may have another kind of phase. So, base metal, heat affected zone, fusion boundary, weld metal, all these may have the different phases. And even if we consider the given metal, in that case, like some of the things may be present within the grain, or some of the things may be present at the grain boundary. So, where what is present among the present phases, that is what is identified through the distribution of the phases, where what is present. Among the grains, we had need to, among the means in terms of for the grain structure, we see that the grain sizes means there are different ways to measure the grain size, like the average diameter of the grain, or the interdendritic spacing, intercellular spacing, depending upon the kind of structure which we have. The grain size is measured in different ways. Then the shape of the grains, the grains are of the needle shape or circular shape or polyhedral or very irregular or star shape. So, or it is in Chinese script form. So, there are different shapes. So, that shape is need to be identified, and there is general way to identify the shape factor is the aspect ratio, wherein the length to width ratio is used to define the shape aspect. Needles will have the greater aspect ratio as compared to the circular geometry or the spherical shape phases. And the distribution means which kind of the grain, distribution of the grains, where which type of the grains are present, like the boundary may be coarser, like in welding fusion boundaries are coarser than the weld fusion zone. Similarly, in the casting, the grains are very fine near the mold wall, and they will keep on growing as we move closer to the center. So, in which way the grain size and the shapes are distributed in the bulk material. So, these the structural modifications. So, whenever heat treatment is applied, either there will be change in type of phases which are present, or there will be change in the relative amounts, their distribution may also be modified. Similarly, the grains structure, grain sizes may be altered, the shapes may be altered, and distribution. So, any change in any of these 6 components can be termed as the change in microstructure. So, basically through the heat treatment, attempts are made to modify these different constituents related to the phase structures and the grain structures. Now, we will see the typical heat treatment cycles which are used in case of the different kind of the metal systems. For example, like most of the steels are heat treated in one way, while the precipitation hardenable alloys are heat treated in different way. Say heat treatment cycle for the steels, mostly it follows the heating for austenitizing, so that the entire bulk material is austenitic, and then we allow the cooling at different rates as per the kind of heat treatment which is performed. So, highest cooling rate is used for the hardening purpose, wherein quenching is carried out. Then somewhat higher cooling rate is carried out for the higher cooling rate is applied, somewhat lower cooling rate is applied for the normalizing. So, only the grain structure is defined, and then further lower cooling rates are used for the annealing purpose, so that softer structure is obtained. So, this is the portion where heating is done. This is the y axis is time or temperature, and x axis shows the time. With regard to the welding, this variation is very high, because welding cycle goes in like this, while the thermal cycle for the heat treatment goes is much longer. So, heating followed by soaking. During the soaking, homogenization of the composition, homogenization of the phases, and austenitization takes place during the heat treatment of the steel. So, annealing is normally done for the softening purpose, for grain refinement, relieving the residual stresses, increasing the strength and hardness. Normalizing is carried out, while for increasing the hardness, wear resistance, normally the quenching of the steel is carried out. So, here now I will summarize this presentation. In this presentation I have talked about the fundamental approaches which are used for enhancing the properties of the bulk materials as well as surface materials, and in which way, what is the fundamental approach for changing the properties or improving the properties of the bulk materials through the heat treatment, like it is altering the microstructure of the metals, and what are the different things that we look into the microstructure, and what kind of heat treatment cycle is used in case of steel. In subsequent presentations we will be talking in detail about the different heat treatment processes for steels as well as aluminum alloys. Thank you for your attention.